Today we're going to be taking a look at this Creality CR-10 Smart printer, and this is one of the latest offerings from Creality, and it's supposed to boast a lot of modern and smart features such as the built-in Wi-Fi connectivity using the Creality Cloud application. Now, this printer also features a built-in strain gauge into the print head that allows you to do the auto bed leveling without something like BL Touch or any other proximity sensor, so that's kind of cool and innovative as well. But this printer was sent to me for free from SainSmart, so I just want to get that out of the way. Check out their website. I put a link in the video description down below. And if you've been 3D printing for any period of time now, you've probably already come across them. They're a distributor of the Creality products, as well as different filaments and 3D printing and maker gear. So go check those guys out. Big thank you to them for sending me this printer for free. But other than that, I have no affiliation with Creality or SainSmart. This is actually my first Creality printer that I personally own. I've used many others. But again, I'm not trying to show you guys this particular product at the end of this video. If you guys do want a machine like this, obviously I would encourage you guys to go check out SainSmart and potentially buy your printer from them if you're interested. But otherwise, if you guys have seen other Creality CR-10 Smart videos, you've seen some good and bad reviews. And I'm here to kind of show you guys a little bit of both. There's definitely some great things about this printer, and there's some things that I think Creality should also work on. So I want to give you guys an in-depth and honest review. I've had this printer now for about 2.5 months, so I've had quite a bit of experience with it. I've run through quite a bit of filament with it, done some small and big prints, and we're gonna get to all that. But first, we're gonna start with the unboxing and assembly.
And so the first thing we'll do here is start off with the unboxing, and you can see that everything comes packaged really well. No surprises here. Nice thick foam protecting all of the parts inside, and you can just take off that top piece of foam which has most of the loose parts in it, and you'll see the main components inside of the printer. It's pretty heavy, so just be careful lifting those out. All of the loose parts are featured here, and there's not too many of them, so assembly should be pretty simple. You get things like the LCD screen, a little bit of filament to start off with, the user manual, a spool holder, the pull rods, power cables, spatula, and some hardware. So now I'll walk you guys through the assembly process, and the first thing I'm going to do is I'm going to remove the gantry from the top of the print platform or printer base. And I'm going to use the included foam just to keep it propped up so nothing gets damaged. I'm also going to remove the glass build plate so that it does not get damaged during the assembly process. So you're just going to flip open those cam locks and set it aside. And looking underneath the printer, this is something I like to do on all of my builds. So taking a look at the electronics underneath and the wiring just to see, how good of a job they've done, make sure nothing is loose or looks like a potential fire hazard. And in this case, it looks like Creality did a fairly nice job of keeping things neat and tidy under here. The power supply is branded a Creality power supply. So normally I'd look for something like a brand name like Meanwell. In this case, it looks like they're either rebranding their power supplies or making their own, which is kind of interesting. But in the bottom underneath the power supply, you have the relay board, which is responsible for allowing the software to turn off the printer. So that's what that is down there. And then there is a Creality Wi-Fi box, and that's basically just the Creality Wi-Fi box product, and they've taken the PCB and put it right into this printer. There is the main board, of course, and there's like a little USB distribution board kind of in between those two. But some other nice to see things are just attention to detail, like grommets anytime the wires pass through the sheet metal, especially on that heated bed cable, so that was nice. Things like frame grounding, which is also nice to see. So overall, it should be pretty trustworthy. With the base now already on its side, it's a good time to install and get the gantry button down. So working on a flat surface, you can see that I got the print head overhanging the edge of the table such that the extrusions should be nice and square and flat to one another. And on the bottom side of the printer, you're going to take your M5 socket headed cap screws. There's 4 of them. Get them tightened down. And you'll see that on the extrusions, there's machined surfaces, and that's where your uprights are sitting so that the assembly should go together fairly square. And what I would highly recommend doing for this printer, as well as any other print build that you do in the future, get yourself a framing square or a combination square like this one, and make sure that all of your extrusion members are always square when assembling your printer. This is really going to help you in the future with troubleshooting print problems, because knowing that you put together your printer with a high degree of accuracy is going to eliminate a lot of weird issues when it comes to troubleshooting later on. And so these pull rods are intended to give the vertical uprights on your printer a little bit of extra stiffness and bracing, but they can also be used to make minor adjustments if your frame is not square. In this case, my frame was very square, so I'm not going to try and make adjustments with them. But they also come with this hardware, so it's more M5 hardware. These are button head cap screws, so the short one goes in the top, the long one goes in the bottom. And I've loosened off the joints in the top and the bottom so that I can make adjustments to those joints such that the pull rods, like I had said, are not pulling or pushing on those vertical uprights because they're already very square. So I just want to tighten those down using the M5 hardware, and then I can tighten the nuts on those pull rods. And so you can see me here again checking the squareness to make sure that I didn't adjust it. Over here you can see the nuts that I'm going to tighten down. You may also notice the washer there. I did put it on the wrong side. I will correct that later. So that washer should go between that pull rod and the frame. Up at the top, I did not move my X gantry down while I put the pull rods in, but if you're having a hard time working in that small amount of space, or if you're finding that it's interfering, then you may want to push the Z-axis down manually before installing the pull rods. One thing I'm also going to check here is I'm going to check how parallel this X gantry is in comparison to the top member of the frame. And in this case, it's pretty much bang on. Again, this thing has dual Z rods, so you could, I guess, essentially adjust those independently if you had to. And we might get to that a little bit later, so we'll check to see how level and how true the X gantry is to the print bed later on. But in this case, I'm just again checking the squareness of the frame all around because this is again going to help us later on, ensuring that any problems we encounter are not related to the mechanical build of the printer. So now I'm taking a look at the spool holder. Mine came from the factory broken, so I'm not going to be using this thing. But because it's broken, I got to see the insides of it, and it looks like they're using actual bearings, which is nice. Some of the more traditional spool holders from the older machines are pretty cheap and not really that functional. In this case, it could be a very good spool holder if it wasn't broken. And it would attach to the side of your machine using these T-nuts here, and so they would just slip into those channels on the side extrusion. You can tighten them down with your Allen wrench, and a nice little feature as well is if you're not using it, it does fold in. Now we can move on to the assembly and installation of the LCD screen. So there's a connector that just simply connects and pushes into the back of the receptacle and the back of the screen, and then from there you can just take the screen and push it towards the printer and then down, and it should click and lock into place. Now we have a few more electrical connections to take care of here, and so we're going to be connecting the connectors to our two Z stepper motors. So those are the one on the left hand side here, and I'm going to reuse the tape just to make sure those wires stay down and they don't get caught on anything. Then there's the second Z stepper motor, the one on the right hand side. So just push those connectors in. They're keyed, so you can't put them in backwards or anything like that. Again, I'm using the tape to secure those wires down, and then this is the result. So nice and neat and tidy. And looking at the front of the printer on the left hand side, there's the connector for the optical Z end stop, and so you can simply just plug that in as well. Now we also have the connectors that go up to the print head and the extruder motor, and these again are keyed and you can't confuse them. They won't plug into one another, so just simply plug those two connectors in. And there's of course the power connector on the back of the printer. From there we can take the protective film off of our build plate, and we can put our build plate back onto the printer, and we have not damaged it during the assembly process, so that's great. Use the two cam locks on the front to tighten it down. Flip the switch on the back of your printer to the on position. You'll see an LED light up, and on the right hand side, press and very firmly press that big silver button and your printer should turn on. The Creality logo will show up in a pretty slick little animation here, and you'll be presented with a new to Creality user interface. So I don't think this appears on any other printer, and it's just on the CR-10 Smart version. And so it has several different little settings that you can go into. In this case, there's the bed leveling, so I think that's a good place to start. So I'm just going to press start on the auto bed leveling, and let's see where that takes us. So it appears at first that nothing is happening, but it's actually heating up the nozzle, and so it's going to heat that up, not quite to the print temperature, but it's going to wait for that to finish heating up, and then it's going to start the probing process. So on the CR-10 Smart, there is a strain gauge inside of the print head, and it actually uses the nozzle and the whole print head itself to press onto the build plate, and that tells the printer its position and how close it is to the print bed, so it knows that it's touching. It'll probe the print surface in 16 spots, and it should save all those as a mesh, and then it should be able to compensate for any irregularities in the print bed. Now, I have this particular problem here where the probing fails, and it left a nice gouge and scratch in my print surface, and this appears to be the culprit. So one thing I failed to check was the tightness of the V-rollers on the y-axis, and that was the main problem. However, there were some other issues, and in the interest of not making this video too long, I covered that in a separate video. So I'll put the link to that video in the top right hand corner of the screen right now, because there was a few other minor things to adjust. And again, I didn't want to really get into that into this video, but it was a problem that I had with this printer and some other people have. So check out that video if you happen to have auto bed leveling issues. Now, that being said, the corrections that I did make to the printer resolved my issue, and you can see here that all 16 sectors completed, and I'm ready to move on to the next step of printing. And that next step would be to get some filament loaded in. So we got this filament guide here that goes between the extruder and the filament runout detector, and you can see I've also flipped open the lever on the extruder, so that's going to allow us to manually push filament past the extruder motor. So first I'm loading it through the filament runout detector, through that clear filament guide, through the motor, and then now you can see it pass through the Bowden tube. I'm going to push that up pretty much right to the hot end. I have not preheated the hot end just yet, and we'll get to that in a moment. But I'm going to get that filament loaded right up into the hot end, and then I'm going to close the lever on the extruder motor, and that's going to lock it in place and allow the extruder again to push the filament through. Now we can prime the nozzle, so we're going to go into the prepare section of the user interface, hit preheat PLA, and you can see your nozzle temperature start to rise. Mine was already at 120 from the auto bed leveling procedure, so it's only going to go up from there up to the 205 degree printing temperature for PLA. Within the prepare section, while that's going on, we can take a look at a few other options. So there is a section for the feed and return and the axis movement. So feed and return, you can feed a certain amount of filament through the extruder, of course, and you can do that just by clicking on the number, selecting, let's say 10 millimeters, and hitting feed. In the axis movement, this is where you would manually move the Z, X, Y. You can home the axes, and in the bottom left-hand corner, there's a little symbol that looks like a motor, so you could disable the stepper motors if you wanted. So I'm just kind of clicking on a few things and moving the print head around right now. But in feed and return, this is where I'm going to now feed through, let's say, about 50 millimeters of filament to prime the nozzle and purge out the white filament that comes in there preloaded from the factory. So I'm just purging that out, and you'll see my red filament come through, and we should be ready to start printing. One thing I did find curious is that for a printer that brands itself as Smart, it does not have a one-touch filament load and unload feature in the user interface. So that seems to be missing that a lot of other printers have. Now we need to slice some files and get them on the printer. And I guess what would be considered the smart way of doing this is using the Creality Cloud app. And so I've downloaded that. You can hit print on the bottom and then add a device on the top. Scan the QR code on your printer. And that is going to pull up this menu here where you can hit Bluetooth settings. In there, it's going to allow you to connect to your local Wi-Fi network. So I've kind of cut this part out of the video so you don't see my Wi-Fi network and password. But once you enter that information in those credentials, it's going to connect to your local Wi-Fi network. A Creality device will pop up once it's connected, and you can just click on that device and you'll see up in the top it says CR-10 Smart, so it's been successfully connected. Now we have the ability to do things like control the printer settings directly from our wireless device. And so I'm kind of clicking all over the place here because this is the first time I'm using it. But I'm in the hot heated bed section here, and at the bottom there's a little scroll wheel there. You can scroll through to 60 degrees. I can hit done, and the set temperature on my printer pretty much instantaneously changed. So it is in fact working, and you know, it's pretty cool, but we still got to get files on there. So let's figure out how to do that. So I've set the temperature back down to 0 while we figure this out, and right in the middle there's a button that says select slice. So if I click that, you can see here that it's accessing the cloud slicing and upload section, to which I have yet to upload anything. The Creality Cloud app has a really good help section where you can find the different methods of getting the slice files in there now. And so one such way is to go through Cura. And now I personally don't like Cura, so I won't be using it myself, but the big advantage here is being able to interface directly from Cura right to your machine. And so it walks you through how to do that, and the skin version of Cura for Creality comes on the USB stick that comes with the printer, so you can install that on your computer if you so wish. And again, the help section will take you through that method, and I won't be doing that. You can also get files directly transferred from Thingiverse, and I think there's probably a little bit of controversy around that. I've seen that in some other CR-10 Smart review videos where files could be potentially being stolen from Thingiverse without crediting the original content creators, but that is a way to do it. In my case, for my first prints, we're going to be using PrusaSlicer. And so PrusaSlicer has been my slicer of choice for some time now, and if you head into the configuration wizard and head over to the Creality printers, it just so happens that somebody has made a profile for the CR-10 Smart. Now it's labeled beta, but I've been using this profile now for a few months at the time of making this section of the video anyways, and I've had no major problems and the prints turn out great. We'll get to that in a few minutes. But yeah, all of the presets for the machine settings are all in there, and that saves you a whole bunch of time setting things up in PrusaSlicer. And that includes the start and end G code, and this machine requires some custom start G code. There's a little piece of paper that comes with the machine and it warns you what not to do in your start G code. And so somebody has already taken care of that for you. So if you want to use PrusaSlicer, which I would highly recommend, you can go ahead and get that profile. And if you click on the little gear setting here, one other great thing is that if you set up OctoPrint with this printer, then you can pretty much directly upload to OctoPrint and you'll have a wireless setup just like the Creality Cloud, except using a more superior OctoPrint. And so if you guys want to see how to use OctoPrint with the CR-10 Smart, click on the video link in the top right hand corner of the screen. I didn't include it in this video because technically it's a modification to the printer. Unfortunately, you can't simply just plug in a Raspberry Pi into the USB port on the side of this printer. So you have to actually modify the printer a little bit. That USB port is strictly for Creality USB cameras. And so using the tried and true SD card method, I took my sliced files from PrusaSlicer, put them on the SD card, inserted the SD card into the front of the machine, and pretty much just hit print. And full disclosure, this is not my first print. So if you remember back to the section of this video where I did the auto bed leveling and had some failures, I did some experimentation with the manual bed leveling. And just to be clear, like this printer does not have traditional bed leveling screws. And so there is a section where you can do some sort of, I guess you could call it manual or auxiliary leveling or something of that nature. To me, that was not intuitive at all, and it certainly did not work for me. So I had a huge series of failed prints while I was troubleshooting my auto bed leveling problems. But once I got that resolved, you'll see this is one of my first prints after getting the auto bed leveling problem resolved, and it turns out really, really nice. So I purposely selected a model that spans a large portion of the print bed, and I did it in a diagonal orientation here. So I really try to get the auto bed leveling working in such a way that it's compensating for any deviations in the print surface. And I had no problems with layer adhesion here, and this large model over the large diagonal section of the bed stuck really exceptionally well to the print bed. The printer performed nicely, as you'd probably expect or hope to expect from a machine like this. And you can see that even at the 0.25 layer resolution, the layer lines aren't all that visible. The infill on the top is nice and smooth, that top solid infill. Numbers on this piece here came out legible and nice. Even the ones on the side are a little harder to see in this clip, but I did put some numbers on the side of this part, and those came out also legible and clear. So overall, this was a great success. However, one other problem that I ran into here is that you'll notice that the print has finished. I haven't removed it yet from the print bed, and I want to now end this print, but it's stuck at 99%. So the interface is showing 99%. The print did in fact finish, and I'm trying to cancel the print now, but the interface just locks up. And one very inconvenient and potentially unsafe thing, it's not likely to cause a fire, but something that I just don't feel comfortable with, is that the nozzle does not turn off. So if the print is left unattended and it finishes and you can't get back to the printer for a few hours, your nozzle is going to be sitting at that print temperature for several hours until you can go and manually shut off the machine using the switch at the back. Now I've noticed that this problem only exists when I'm using the SD card, and I've sliced with PrusaSlicer. So this doesn't happen when you use, let's say, the sample models that are included on the USB stick from Creality, and those have been sliced in Cura as well as Simplify 3D. So if you inspect the actual G code, some of them actually they didn't even slice using their own slicer, which is kind of funny. But anyways, it doesn't happen with those files, and I've inspected the NG code with PrusaSlicer, and there's nothing in there that really stands out to me that should be causing the printer to hang. So I really don't know what's going on there, but I also noticed that it doesn't happen when you're using another print host. Like let's say you plug the printer directly into your computer use Repetier host, or you use OctoPrint. You don't get that same sort of problem happening. So if you guys want to learn how to use your PC using Repetier host or OctoPrint, again, there's the video that I linked to earlier in this video, or just go to my channel and check that out. You'll find in there how to set up OctoPrint and modify this printer to use OctoPrint or plug directly into your PC, because there is some minor modification required. And what you're watching now is another print, and this one is of a hand, and it's printing upright, so the hand looks like it's going to be reaching right out of the print bed. It's actually one of my favorite prints to print, and it's got a lot of nice curves, it's a hand, so it's very organic shape, and it really speaks to the capabilities of the 32-bit processor on board here, as you really don't see much in terms of like facets or anything like that, and that's partly the printer as well as the slicer in combination of the two. But the print moves are very smooth with the 32-bit processor. So it is a really nice machine in terms of the quality that it can produce in the prints. And mechanically, it's also quite good. Even though it doesn't use things like linear bearings, it uses those V-slot wheels. But it does make really nice looking prints. And so here's just a little bit of a closer look at some of these same parts under a different light. And so you can see along the long face of the print, things are looking quite smooth. There's really no starts and stops in there, so that's not really a great test of ringing or ghosting. But on the top anyways, again, you can see the legibility of those numbers as I had mentioned earlier. So those turned out great. Pretty much this part looks, like I said, quite good. I think it's more than acceptable for this quality or level of printer, and I'm quite happy with that result. Taking another close look here at this hand, you can see that it is definitely really smooth, and I've printed this model on a few different machines now, perhaps 3 or 4 different machines, even ones with direct drive extruders, and I would say that despite this machine, even using a basic Bowden tube setup, it's probably the smoothest one that I've yet to print. And That says a lot, considering that some of the other machines that I've printed these on have been, like I said, direct drive machines that I have custom built. So for a printer kind of out of the box, that's a great result. This one is a print that I like to use to test overhangs, and there's a feature on the other side which is kind of hard to see in this view, but I'll show you that in a second. And it sort of starts and stops on this steep overhang, and a lot of times on some printers you'll see things like curling if the part cooling fan is not sufficient. But in this particular case, you can see here that I have the cooling on throughout the whole model at 100%, but those details came out very sharp. There is a little bit of bulging I noticed on this printer for sharp corners, so that does exist on these prints. But overall, those edges and corners are quite sharp, and I didn't see any signs of curling or warping or sort of weird artifacts on the steep overhang section of this part. So overall, these parts also turned out quite nice. This is a part that I used to test for dimensional accuracy, and it slides onto that long bar that I showed you earlier. And so it slides on with minimal effort. So I would say dimensionally, the printer works very well and it's quite accurate. The numbers at the bottom here I use as a test for the first layer quality, and you can see all the numbers are legible. There's maybe only one that's ever so slightly squished, so I would say that the auto bed leveling works very well. The horizontal and vertical holes came out really clean, and you can see there that even at 0.25 layer resolution, that horizontal hole looks really nice. And there's a little bit of bulging in the corners, which I'm going to try and fix a little bit later by changing some of the acceleration and jerk settings, but as of right now, I have not yet addressed that. After all of those beautiful prints, I did have this unfortunate accident happen, and so I gained a lot of confidence in this printer and I left it unattended for longer and longer periods of time, and eventually I came back to my hot end encased in plastic because clearly something went wrong and it didn't stick to the print bed. So I had to take off the cover for the hot end because I had to clean the hot end off and get rid of all that plastic. So there's just 2 hex screws in the front, and then there's one around back as well. So that's on the bottom, and just you're going to use a simple Allen or hex key, and then with those undone, the whole cover will just simply pull off of the hot end. With the cover off, we can now take a look at this fairly unique hot end, and it's quite a bit different than what you might be used to seeing on most Creality machines, since they've pretty much copy and pasted the Ender 3 hot end with maybe minor variations across most of their platforms. So this is quite a bit different. The strain gauge is built into there, like I had mentioned earlier in the video, and that performs the auto bed leveling feature. But one of the coolest things that I can kind of see here is the heatsink fins, and you can see those wavy looking fins in there. And those are what I think, or what I interpret for the design intent, is to direct that air that cools the heat break, and to direct it away from the nozzle as to not inadvertently cool your part. So obviously the part cooling fan is what's responsible for that, and the air will get directed out of the side of the hot end. So that's pretty cool. With the nozzle cleaned up and the cover back on, I decided to load in some higher temperature black PLA and test out some larger prints. So I went for prints in the 8, 9, and 10 hour range. And maybe, you know, that's not day-long prints, but they're still quite long, and I would still consider them perhaps, let's say, endurance prints. And all of the models turned out excellent. I would say that the printer was very reliable over this period of print time. There were no weird artifacts on the print. It was all very uniform. So great, repeatable, and predictable behavior here. So where does that leave us then with the final verdict for this machine? Well, I'm going to take you guys through some of the positives first. So definitely the machine construction is a big positive. It's a solid machine. It's a nice looking machine. They did pay a lot of attention to detail with this sort of thing. So even things like wire management looked like they did a serious job on this machine, with strain release on the heated bed, for the wire bundle going up to the x-axis, grommets for any wires passing in and out of the sheet metal enclosures. So that's really nice to see. Injection molded covers on all these parts so you can't stick your fingers in there. Even under the machine, when I took off the bottom cover, the wiring looks like they did a decent job. It was neat and tidy, looks relatively safe. Things like adjustment knobs on the X and Y axis for adjusting the belt tension on those axes. That's also convenient and well thought out. They also seem to work very well. The printer comes with a fairly comprehensive toolkit that pulls out from this nice little drawer in the front here. And this is where you're going to find things like the USB stick, SD card, nozzle tool, 10mm wrench, Allen keys, nozzle cleanout tool, snippers, even a spare nozzle comes in there, and some extra spare parts. So that's really nice to see, especially for a printer in this price range. The other big positives of this machine is that it mostly delivers what's promised from Creality, so the connectivity through the Creality Cloud app is quite easy to set up, and it does work well, although it is a little bit limited. And other things like the auto bed leveling system with that strain gauge, it does work really well, and it's fairly repeatable and reliable. Haven't had too many problems with it after I set it up properly. And the other big positive of this machine is that it's quiet. Now, some people online have complained about the fan noise, but I don't know, I'm not really sure what they're complaining about. It's fairly quiet and you're running a 3D printer, so I would think that you would expect to put up with just a little bit of fan noise, but the stepper drivers are completely silent, so it's definitely not an annoying printer to use in your home or office. Now, in terms of the negative aspects of this machine, there are a few. The first one being that it's quite slow in terms of the pre-printing setup. So trying to heat up your nozzle and heat up the bed is a very slow and painful process. And I'm not sure why, because I have printers with the same sort of size of heated bed and it's not quite this slow. So I'm not really sure why that's going so slow. But also, even in terms of the auto bed level probing, not that the probing has to be done before every print, but when you do have to do it, it takes a really long time. They have the print head moving extremely slow. I don't necessarily think the travel moves have to be that slow, but that's just a little bit annoying. Things like in the user interface, there is no one-touch automatic filament load and unload. And it's not a huge deal, but when you're calling your printer smart, I feel like that should be a pretty basic smart feature that's included. Also, because we're talking about the user interface, it's a nice interface and it's very responsive, it looks nice, but there are a lot of features and adjustments that are missing from there that I think they could be included in a future firmware update, where, like I said, more basic machines just allow you to dive deeper into the machine settings and firmware from the user interface touchscreen. Speaking of firmware, I think this is the biggest letdown of this machine. I think Creality should have done a lot better of a job of testing and debugging the firmware before releasing it onto the market. I have this problem where you've seen early in the video where my print finishes and the printer freezes up and it's no longer responsive, and that leaves the nozzle on, which I don't really feel comfortable with. I don't like that, and hopefully a future firmware update fixes that problem. As well as things like the manual leveling. I was just never able to figure that out. The user interface in that sense is not very intuitive. And it wasn't until recently, even like 2 months into owning this machine, I realized that you can, while printing, or at least while preparing the print, you can click on the little icons on the side of the home window there where you start printing, and you can actually make on-the-fly adjustments to the Z compensation. The user manual does make reference to making this adjustment, but it's not clear on how to get there. So getting to that, like I said, Z offset and Z compensation is rather difficult and definitely not intuitive. And so overall, I do actually like the machine, and it is a machine that I will be keeping and printing with on a regular basis. I do think it makes nice quality parts. They look nice. The quality and dimensional accuracy of the parts is great. So it's not that I have a problem necessarily with what it's putting out in terms of parts. It's just that user experience in getting it to the point where you're getting those nice parts reliably and repeatably. So it's not necessarily a knock on Creality, because this is the general experience I've had with all of these, let's say, sub $1,000 3D printers that mostly come from China. I just find that there is a little bit of lack of quality control, as well as development, like factory development, and releasing a polished and finished product. These companies seem to really heavily rely on the 3D printing community to identify and address the shortcomings of the machine, and then maybe later on they issue a revision in the firmware or something to fix those problems, but they seem more concerned about putting out more and more new machines. And I think Creality is probably one of the worst offenders of this. They have so many machines in their lineup that it's actually rather confusing to me. It seems like there's really not much of a focus in terms of the different machines and how they differ from one another. It's like each machine has a random number of features and you kind of just randomly pick a machine that you think is going to work for you. I really think they should be trying to consolidate their lineup of 3D printers into something smaller and then focusing on the development of those existing platforms rather than constantly coming out with new platforms.
So that's it for this video and the review of this particular printer here. Big shout out again and thank you to SainSmart for sending me this printer for free so that I could review it and make this video. If you guys are interested in buying something like this, I would highly recommend that you get it from SainSmart. So go check out their website. Link is in the video description down below. Other than that, you'll see a lot of future videos on this machine, how I'm modifying it and how I'm using it for different projects. So keep an eye out for those and consider subscribing to my channel if you like my content. Thanks for watching.